Every day, India moves over 70% of its goods by road. Raw materials, fuel, food, and medicine all rely on long, narrow corridors that cross fragile terrain. When a landslide severs a Himalayan route, or when floods wash out a bridge, the effect isn't just local. Clinics can run short on oxygen cylinders, neighborhood markets see vegetable prices surge by 30%, and fuel queues can snake for blocks. These aren't rare disasters. They are routine stress tests for supply lines that matter not only to truckers, but to entire regions and balance sheets. In this story, singular road failures trigger chain reactions across the economy, exposing what keeps the nation's trade moving, a hidden architecture of risk, redundancy, and real-time adaptation. But how close does the system run to the edge, and what happens when it falters? India's most critical logistics corridors are shaped as much by geography as by engineering. Each year, the Himalayan belt alone records around 150 landslide-induced road closures, with some high-altitude passes blocked for up to 15 days at a time. These aren't isolated incidents. They are routine disruptions that ripple across the supply chain. In the floodplains of the Ganges and Brahmaputra, highways face an average of 42 major flood-related washouts each year. Each event can close key stretches of road for 3 to 7 days, sometimes erasing entire segments and forcing detours that add hours or days to delivery times. Aging river bridges present a different challenge. On corridors like National Highway 37 and National Highway 44, 68 incidents of load restriction or outright closure have been logged in the past 4 years, each lasting an average of 48 hours. During these periods, truck weights are capped, forcing companies to split shipments and schedule additional runs, raising costs and delaying deliveries. Heat stress is no less disruptive. On National Highway 44, India's busiest north-south artery, pavement temperatures exceed design limits on about 30 days each year. These heat events trigger rutting and softening of asphalt, requiring maintenance crews to intervene up to a dozen times each summer. Temporary speed limits and lane closures are imposed, slowing freight movement and compounding congestion. Each hazard, landslide, flood, bridge fatigue, or heat, translates environmental volatility into a chain of interruptions. A landslide blocks a pass, and trucks back up for kilometers. A washed-out bridge severs a supply line, and inventory at regional warehouses drains away. A heat wave deforms pavement, delivery windows close, and perishable goods risk spoilage. These are not rare shocks, but persistent features of the risk architecture that governs India's supply corridors. The result is a logistics system that must constantly absorb, reroute, and recover from the terrain's demands, with every closure or restriction echoing through inventories, prices, and operational costs. When a landslide buries a mountain pass or a bridge suddenly closes, logistics firms don't wait for repairs. They pivot. Route diversification becomes the first tool, powered by real-time GIS mapping and risk scoring. Dispatchers, acting as the nerve center, scan live data on weather, traffic, and infrastructure. If a main corridor fails, trucks are rerouted, often adding 15 to 20% to the journey. On a 1,000-ton-kilometer route, that means 1,800 rupees more in diesel and 3 to 4 extra hours, a costly delay, especially for perishables. Redundancy extends beyond the road. Buffer warehousing in regional hubs like Chandigarh and Guwahati holds safety stock set to cover 2 to 3 days of average demand. This is not guesswork. Inventory levels are set by a heuristic balancing daily throughput, lead time, and service targets. When a corridor is disrupted, these warehouses release pre-positioned goods to keep markets supplied. If stock dips below 70% of target, companies may turn to premium freight, air, or chartered trucks, raising costs by up to 30% and pushing prices higher downstream. Staggered dispatch adds another layer. By shifting truck departures by 6 to 12 hours, Based on weather models and disruption history, firms avoid having entire fleets stranded by a single event. This strategy, guided by probabilistic algorithms, has cut average delay costs by about 12% for major carriers. Together, route diversification, buffer warehousing, and staggered dispatch form a system built to absorb shocks before human judgment is truly tested. Long-haul drivers on India's fragile corridors work at the edge of human endurance. Regulations cap driving at 9 hours a day, but field surveys show only about 62% compliance, especially during peak disruption seasons. In practice, drivers often push through 12-hour shifts, sometimes sleeping less than 5 hours before setting out again. This pattern is not a matter of bravado. It is a systemic response to tight delivery windows and the unpredictability of route failures. Accident data from the National Crime Records Bureau reveals that drivers exceeding the legal work hour limits are 1.4 times more likely to be involved in crashes than those who comply. The risk is not just on paper. Every hour behind the wheel under fatigue amplifies the chance of a costly incident, from minor fender benders to multi-vehicle pileups on steep Himalayan slopes or heat-buckled highways. Cognitive strain is measurable. Studies from the Indian Institute of Technology show that when drivers face sudden detours, like a landslide or a washed-out bridge, decision-making slows by 30%. That extra second of hesitation can mean the difference between a safe stop and a catastrophic error. The effects compound under heat stress. During the summer of 2022, more than 1,200 drivers on the National Highway 44 corridor sought medical attention for heat-related ailments. Shade and water are not guaranteed. Only 45% of truck stops along major routes offer both. These numbers reveal a system where operational resilience depends as much on the human bandwidth of drivers as on any engineered redundancy. The margin for error narrows with every extra hour and every degree above safe limits, making driver fatigue and health a silent but critical point of failure in India's logistics architecture. A landslide on NH10 near Kalimpong in July 2021 sends 15,000 cubic meters of debris across 12 kilometers of highway, closing the route for 48 hours. Dispatchers at logistics centers reroute trucks onto NH31, adding 3 hours per trip and raising diesel costs by 1.5 million rupees. Inside Kalimpong's cold storage warehouse, 400 tons of vegetables are gone in 36 hours as retailers rush to restock. Warehouse managers in Siliguri and Gangtok authorize emergency releases, drawing down reserves at a rate usually seen only during festival peaks. As inventory thins, prices in Gangtok climb. Vegetables jump 30%, with tomatoes rising from 30 to 39 rupees per kilogram. Buffer hubs in Chandigarh and Guwahati respond to parallel disruptions, releasing 800 tons of food grains and 600 tons of medical supplies within 12 hours. Staggered dispatches, guided by probabilistic algorithms, keep staple inflation under 5%, far below the 12% projected without buffers. Each intervention, including rerouting, emergency stock releases, and algorithmic dispatch, leaves its mark in fuel bills, insurance claims, and market prices, making the chain of consequences visible in daily commerce. On the Srinagar to Leh highway, a 12 billion rupees slope stabilization effort has changed the way landslide risk is handled. Rock bolts and geotextile walls now hold some of the region's most unstable ground, and early warning sensors monitor soil shifts around the clock. The state engineer reports that landslide closures have dropped from 4 to 1 per year on improved stretches, but 30% of the Kargil to Leh segment still lacks reinforcement. Even with sensors, not every threat can be caught. Flood-prone corridors present another test. National upgrades have begun, embankments raised 2 meters, and bridges retrofitted with scour mats. Highways like NH31 and NH44 remain vulnerable, with just 15% of planned flood upgrades finished. Hydraulic modeling guides the work, but progress is slow and costly, especially with live traffic. Digital shields now supplement concrete ones. On NH37 in Assam, a pilot network of 25 sensor streams real-time data, offering a 2-hour warning before slope failures. Yet the system is not flawless. 8% of alerts are false positives, and a 6-month procurement gap left coverage patchy. Progress is measured in kilometers reinforced and minutes gained. Every idle hour for a truck on a blocked corridor adds costs that ripple through the entire supply chain. The baseline delay cost for Indian road freight is 12 cents per ton kilometer. On the 10 most vulnerable corridors, annual losses reach $1.5 billion, not counting extra fuel for detours or added wear from rough bypasses. Insurance premiums rise sharply on high-risk routes like NH10 and NH31, where carriers pay 15 to 20% more due to frequent claims from cargo damage and spoilage during long delays. Buffer warehouses, stocked to cushion these shocks, bring their own financial weight. The capital locked in safety stock, plus warehousing and spoilage, totals millions each year. On NH44, carrying buffer stock alone costs nearly $30 million annually, excluding the price of emergency shipments when inventories run low. Yet redundancy has limits. Probability models show a 0.8% chance each year that a monsoon flood in the east will overlap with a heat wave or landslide in the north. When these compound events hit, only 55% of normal freight capacity remains. Direct costs can jump by $36 million, with regional price spikes in food and fuel adding another $18 million. As one logistics CFO notes, redundancy is not a shield, it is a fuse. For India's logistics corridors, resilience is not theoretical, it is a daily operational imperative. As supply routes grow longer and climate volatility intensifies, every hour of disruption compounds across economies. In a world built on just-in-time delivery, the cost of fragility is paid in real time and by everyone.